of reaction. It is an enthalpy change of a chemical reaction that occurs at constant pressure. It is used to calculate the amount of energy per mole either released or absorbed. On the other side, it measures how much heat is released or absorbed by each chemical of a substance during the chemical reaction. I have here two chemical equations. The first one is calcium oxide reacts with water to produce calcium hydroxide, and second, nitrogen reacts to oxygen to produce 2 moles of nitrogen monoxide. Which equation do you think shows an endothermic and which equation shows exothermic? The first equation illustrates an exothermic reaction. In an exothermic reaction, the heat is released is written as a product and has a negative sign. This equation means that each mole of calcium oxide and water that reacts to calcium hydroxide, 62 kilojoules is released. Meanwhile, the second equation illustrates an endothermic reaction. In an endothermic reaction, the heat released is written as a reactant and has a positive sign. This equation means that nitrogen and oxygen release 181 kilojoules. The second equation shows an endothermic reaction. In an endothermic reaction, the heat absorbed is written as a reactant and has a positive sign. This equation means that each mole of nitrogen and oxygen react to form 2 moles of nitrogen monoxide. 181 kilojoules is produced during the reaction. Evolving enthalpy changes are solved similar to stoichiometry problems. The amount of heat absorbed or released depends on the number of moles of the reactants involved. For example, calculate the amount of heat in kilojoules required to decompose 4 moles of
iron oxide. Here is the chemical equation. 1 mole of iron oxide reacts to 3 moles of carbon monoxide to produce 2 moles of iron and 3 moles of carbon dioxide. And to solve the change in enthalpy, we need first to balance the equation. And since it is already balanced, we are going to get the conversion factor. Based on the problem, the required or the unknown amount of heat required to based on the problem, we are going to get the amount of heat required to decompose 4 moles of iron oxide. And since we are looking for the iron oxide, we are going to get the proportion or the ratio. We should ask ourselves first, how much heat is released by 1 mole of iron oxide? Thus, 1 mole of iron oxide released 26.3 kilojoules. Next is that we are going to substitute what is needed in our formula, which is given mole times our ratio, the conversion factor. Just reciprocate it. Reciprocate it. So, given mole from the problem is 4 moles of iron oxide multiplied by the conversion factor, the reciprocate conversion factor, negative 26.3 kilojoules per 1 mole of iron oxide. We're just going to cancel the mole of iron oxide and multiply 4 and 26.3 kilojoules. Thus, to decompose 4 moles of iron oxide, the reaction needs to release 105.2.
Positive change of enthalpy means addition of energy, which is written as reactant and shows endothermic reaction. Negative change in enthalpy means removal of energy, which is written as a product and shows exothermic reaction. That is heat of reaction.